Hello and welcome to Section 8.2, the Pythagorean Theorem. This may be the most important lesson that you learn in math. The Pythagorean Theorem is huge, 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 huge. By the way, something smells weird in here, and I hope it doesn't bother you like it does me. But anyway. All right, first of all, we got to give credit to Pythagoras. He was this Greek philosopher who came up with the Pythagorean Theorem. Never figured out why they call it the Pythagorean Theorem, but this guy named Pythagoras came up with it. Here's the deal. In a right triangle, we first need to understand these parts. The side opposite the right angle is called the hypotenuse. We've seen that before. What I mean by opposite? Opposite means the other side from the right angle. That's called the hypotenuse. That's an important word for us to be able to talk about freely. It is always the longest side of a right triangle. The other two sides are called legs. You have two legs of a right triangle. The two legs make up the right angle of a right triangle. It's worth noting as well. Remember, it's always the longest side. So here is the Pythagorean Theorem. This is the key thing. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. Now, that sounds like a lot of things to comprehend in one sentence, but let's break it down. We have a hypotenuse over here is C, and then A and B we've marked as the two legs. So the sum of the squares of the legs, that would be A squared plus B squared, equals the square of the hypotenuse. A squared plus B squared equals C squared. And that's the common way that you'll typically see and hear the Pythagorean Theorem rattled off. A squared plus B squared equals C squared, where C is the hypotenuse, A and B are the two legs. There it is, the Pythagorean Theorem, at last. Remember, C is always the longest. Now, what this new formula and theorem allows us to do is that anytime you have two sides of a right triangle, we can now find the third side. So let's go look at these examples. Oh yeah, I was going to show you this proof of where this comes from. There's actually several proofs for the Pythagorean Theorem, but I'm going to use one based on things we've been doing. So here's a right triangle that's broken down. I got an altitude coming off, which breaks it down, which breaks C, the hypotenuse. I still got A, B, and C like I did on the other side. Into D and E, segment F here, the altitude separates into D and E. Going to create some proportions. C over A equals A over C. You'd say, where does that come from? The longest side of the big triangle is over the longest side of the smallest triangle, C over A, equals A, the longest side of the tiniest triangle, over E, the shortest side of the tiniest triangle. A over A, or A and A show up here as both means of the proportion. That is the geometric mean of this proportion. Let's set up one more proportion. C over B equals B over D. Same idea, the longest side of the long triangle over the longest side of the medium-sized triangle, the triangle on the left, is equal to the medium-sized side of the biggest triangle over the medium-sized side of the left triangle. C over B equals B over D, and we end up with another geometric mean of the proportion B. Now, I got two proportions. We can cross multiply each of them. So A times A is A squared equals C times E. B times B, B squared, equals CD. I'm going to go back and do something we did a bunch when we were dealing with in the first semester. A squared plus B squared. If we take these two equal things, A squared and CE, and add them to these two equal things, A squared plus B squared, these two equal things, must equal these two equal things when added together. So we end up with A squared plus B squared equals CE plus CD. That comes from just adding all that stuff up there together. Now the next thing we're going to do, there's a common factor here, C and C. So I'm going to factor it out. Remember that from your algebra. And we end up with A squared plus B squared equals C times E plus D by pulling out that common factor D. Now what is E plus D? Well, look back up at the diagram. D plus E, or E plus D, equals C. That's what C broken down was. So we can replace now the E plus D and end up with A squared plus B squared equals C times C, which of course is C squared. Voila, the formula. So this comes from somewhere. It was what that was all about. Now, we can, if we have two sides, we can find the third. So look at example A here. The two legs are 5 and 12. So 5 squared plus 12 squared equals the hypotenuse squared, x squared. And you just go about solving. We end up with 169 equals x squared. You'll always be taking the square root of something whenever you're using the Pythagorean theorem to solve for legs, or solve for a side, I should say. So we end up with 13 equals x. Look at example B, a little bit different here. This time we have a missing leg. That hurts. 4x plus x squared equals 2 square root of 5 squared. I know you know how to square 4, it's a 16, but how do you square 2 square root of 5? Just to review this process, you square the 2, which is 4, you square the square root of 5, which is 5. Anytime you have a square root times a square root, it gets rid of the square root. The square root squared is whatever it was. So we have 4 times 5 is what's left there. So we have 16 plus x squared equals 20, x squared equals 4, x equals 2. There are always two roots when you take the square root of something. Just like a square root means what two numbers multiplied together equal this. So what two numbers multiplied together equal 4? Well, 2 times 2 equals 4, but also negative 2 times negative 2 equals 4. So there are two roots, but when we're talking here in geometry, lengths of sides, you always discard the negative root. All right, try these 8 down here and using the Pythagorean theorem and see how that works out for you. Pause the video. I'll be back with you in a moment. Okay, I hope that went well. Okay, on to the next piece. There are lots of shapes that have right triangles within them. Rectangles, squares, rhombuses, especially triangles especially isosceles triangles. And that's what these questions are now about. We're going to use things we know about shapes along with this new theory to solve for missing variables. Example A here. We have a rectangle. We know this, that it's a parallelogram. It has a right angle. So opposite sides are going to be congruent. We have a rectangle with 9 and 6. Now, what that means is the diagonal, along with the two sides, we have a right triangle. So you have two sides, two legs with numbers. We have a hypotenuse, that's the variable. 6 squared plus 9 squared equals x squared. 117 is what x squared is equal to. Take the square root of 117. There is a perfect square that is in 117, 9. We can pull that out. Square root of 9 is 3. We're left with 3. Square root of 13 is what x is equal to. All right, the next diagram, we have an isosceles triangle with an altitude. That altitude there will cut the third side in half. So we end up with two pieces down there of 5 and 5, which means we have two right triangles. 5 for a leg, x for a leg, and 13 for the hypotenuse. Set up your Pythagorean theorem. X squared equals 144, x equals 12. On to the third example. All right, we have a rhombus. We know that because we have 4 sides that are congruent on this quadrilateral. Therefore, it's a rhombus, which therefore means that the diagonals create a right angle. They are perpendicular. We have 4 right triangles right in there. All right, if AC is equal to 12, these diagonals bisect each other. We have 2 chunks of 6 and 6 there. BD is 16, so it gets broken in half to 8 and 8. So we have 4 right triangles, all of which have x on the outside. If one side is x, they're all x. And then 2 legs of 8 and 6 that look, each triangle really looks like this. Use the Pythagorean theorem. 36 plus 64 equals 100. 10 is what x is equal to. Okay, if you're listening and paying attention right now, do not write what's about to pop on the screen. 5 times 2 equals 10, and there's the 10. That has nothing to do with the question. So don't write it down. If you did write it down, put an X through it. Thank you. All right, try 9 through 14 right now. I'm going to give you a hint on number 14 before I let you go. There's 2 triangles here. You have a right triangle with 9 and 12 as the legs, so you'll have to find the hypotenuse. Oh, and then look, that hypotenuse is now the leg of another triangle. So there's the trick you got to do on number 14. The others are really a lot like the ones up above. Give 9 through 14 a shot here now. Pause the video, go. Okay, here are those answers. Come prepared with questions if you have them, or come see me and be happy to help you. 15, I want to give you a heads up on this one. Here we have a trapezoid with a rectangle attached to this. So what we can do with this, if this is a rectangle with the properties of a rectangle, this piece over here, which ends up being the leg of the right triangle, is equal to 4 square root of 3. Now, this 5 up here means that this piece down here is equal to 5, which means that the other piece over there is equal to 12. So what we end up with is a right triangle here. We had to break down these pieces to come up with this right triangle of 4 square root of 3 and 12, and then x. Go ahead and solve for x now. I got 8 square root of 3. I hope you did too. Go ahead and try number 16. We have a 3D kind of picture here, but this is kind of like number 14 was. You got to solve for the leg of the right triangle before you can solve for the hypotenuse of the left little triangle that's coming out of that plane. Give that a shot. Did you get 8 for this leg over here? And if you have 8 for the leg, 6 for the other leg, you get 10 for x. All right, last set of questions here. I'm going to help you get this set up. Draw a picture is the way to do this. To find the lengths of the diagonals of a square with a perimeter of 56, what that means is all 4 sides, in order to have a perimeter, add up to 56. It's a square. All 4 sides are equal, so 56 divided by 4 is 14. Oh, look, we have a right triangle. Solve for the diagonal. Do that on your own. I'll show the answer in a second. I'm going to help you get these, all these shapes set up. Number 18 is a rhombus, so draw a rhombus. The diagonals have a length of 18 and 24. What do you know about the diagonals of a rhombus? Yeah, that's right. They're perpendicular, they make a right angle, and they bisect each other. So we end up with a bunch of right triangles that have 12 for one leg, 9 for the other. Now we can find the hypotenuse of one of those triangles. Oh, the hypotenuse is one of the sides of the rhombus. There are 4 of them. They're all congruent. Okay, number 19, we have a rectangle with diagonals. So draw it. The diagonal has a length of 5. The width of square root of 3, we don't know the length, so we have to find it. There's your right triangle. Go for it. And then finally, we have a rhombus. The perimeter of the rhombus is 100, so each piece has to be 25. One diagonal is 45 centimeters, so that's going to break it into 2 pieces, 24 and 24, x and x. So see if you can figure out how 14 centimeters is your answer. Those are the other answers as well. Hope this went well. We just learned the Pythagorean Theorem. That is awesome. I'm tired. I'm going to get a good night's sleep now. Hope you do too. Bye.